This video is on polynomial division. It's section 6.6 in your book and page 86 in your workbook. We're just going to focus on polynomial division with monomials. I might show you a couple other things, but won't expect you to know that for a test. But what we want to look at first is how we can kind of undo the addition process here of getting the common denominator we get, and then we add the numerators, but we can also just split that back apart to its original, having two separate equivalent fractions. Okay, and then if we needed to reduce one or the other, we could. We don't want to be lazy and just try to reduce kind of into each term the just a shortcut way, because people tend to really make mistakes with that. They'll only do what looks like it's easy to reduce, and they miss a lot of the other pieces and get them incorrect. So we call that kind of like bad canceling or bad reducing. So we want to avoid that. So at first, and I would say always split this apart, this division. So we have example 6.37, and this is A. So we have 21n to the fourth minus 18n cubed plus 3n squared, all divided by 3n squared. So we are going to split those back apart. So we have 21n to the fourth over 3n squared plus negative 18n cubed. I write it that way just because it's easier to track and reduce, plus 3n squared over 3n squared. Now I can reduce or simplify my quotient here by using my exponent laws. So 21 divided by 3 would be 7. N to the fourth over n squared is going to just leave me with n squared in a numerator. So I can write that as 7n squared. This one here, I would have negative 18 over 3 is negative 6. N cubed over n squared will just leave me with a positive n. So I'm just going to go ahead and write this as minus 6n. That's pretty straightforward. And 3n over 3n. Now be careful here. Make sure you write that as 1. It'd be very common for people just to kind of leave that off. So my final answer is 7n squared minus 6n plus 1. So really what happened here is what you're going to see later is this 3n squared is a common factor to all three of these. So I really can factor that way too. That's a lead in to our chapter 7 work on factoring. Sometimes, it all works out that way. Other times we don't quite have that. We're not left with a polynomial. We're left with variables in the denominator. So we have some rationals in there. So that's what's going to happen with B. So that's why, again, we want to be really careful with how we lay this out. So to start with, I want you to write this as 3 separate fractions like I did over here. So split this all apart. So go ahead and do that. Just pause the video and do that. I'll do pause also and write that up. And then we'll work on reducing it together. All right, so there I have it all written out. I've split them all up. So I have 8a squared b squared over 2a squared b squared plus negative 6a squared b over 2a squared b squared plus 5a b squared, all divided by 2a squared b squared. So I just took each term of the numerator and put it over the denominator based on this concept here that we would keep the same denominator and just split back apart the operation that's happening. So now we're going to reduce. So we have 8 over 2 would give me 4. A squared over A squared is 1. B squared over B squared is 1. So that leaves me with 4. Now I have negative 6 over 2 leaves me with negative 3. A squared over A squared is 1. But now B over B squared would be B to the negative 1. So I'll write that up here. B over B squared equals B to the 1 minus 2, which is B to the negative 1, which is 1 over B, just reminding you from before. So you can really write that as just 1 over B like that. So I'll write that as minus 3 over B, sorry. And then the last one, I have 5 over 2, that can't be reduced, so I'm just going to leave that as is. A over A squared would leave me with 1 over A, just like we had the same situation with the B, and B squared over B squared is 1. So this is my answer for that. 4 minus 3 over B, so it's 4, and then separated by a subtract. 3 over B as a fraction plus 5 over 2A as another fraction. So I would say the common error people make is they just kind of like, oh, these will reduce and then that with that, but they forget about like the 5 and they don't write it correctly. So just be careful. Really watch your shortcuts if you're using any. Make sure you understand why they work. So just an intro to long division of polynomials and how things work with the remainders and such. So if we recall long division, a lot of people forget this. We use calculators so much now, and rightly so, for especially these kind of problems. So this is our this says identify the quotient and remainders. So what I have here is the divisor is the 16. The part that I'm dividing into, that's called the dividend. Didn't ask for that, but I just want to talk about that. So that's the dividend here, right? Then the quotient is going to end up being the answer. Okay, so the quotient will be here. And then we'll have a remainder over our dividend. No, sorry, divisor, I should say. Okay, so it's always over what we're putting into. Okay, a little tongue-tied there. So let's get rid of these little stray marks and write this up. So 16 doesn't go into 5, right? So I just leave a space right here. Okay, so leave a space. You could put 0, but we really don't want to put any 0 there. So we're going to look at 16 into 57 and just kind of think of like, obviously it's more than once, right? Is it double? Double would be 32, so it's more than that. Let's try 3, and then go 3 times 6 is 18. Carry the 1, just like a little placeholder. 3 times 3 times 1 is 3, plus 1 is 4. Then I subtract. Got to borrow there, so I get 9. And then I bring down the other 9 here, okay? So now I'm doing 16 into 99. And I think, okay, well, that's pretty close to double, right? Well, more than double. So I'm going to put a 3. Not a 3, but double that. Sorry, 6. 6 times 6 is 36. 6 times 1 is 6, plus 3 is 9. And I subtract, so I have a remainder of 3. So how I would write this would be the quotient. And this is the remainder. And we write it as quotient. The remainder over divisor. Just like we've done for mixed fractions. I mean, it's probably been a little while for this, so that's why I'm reviewing a simple one with the vocab. So how I would write that is 36 and 3/16. And then I would reduce that fraction if I could, but I can't. So that's my answer for that. So now we're looking at page 87, and we have the same thing I wrote earlier, and so there's just some more details of that formally. So example 6.39, divide using long division, find the quotient and remainder. So these are a little more complicated. These are called rational functions, and we are dividing this trinomial by a binomial. So we'll just show you how that looks. So we have, what is this color? X plus 2. So we put our divisor into our dividend here. X squared plus 9x minus 10. Now if we didn't go like in consecutive descending order of power, we would want to like leave some placeholders there too. Then again, we have to look this whole thing here, x plus 2, that doesn't go into 4x squared by itself, but it will go into the next segment here. So we're going to look at, actually, I'll just read that out. Does x plus 2 divide into 4x squared plus 9? So look at what times x would give you the 4x squared. We want to focus on that one. So we're going to write 4x, and we write it over here just like we had to leave that space when we were doing long division with numbers. We have to leave that same kind of space. Let me go back to that. So if we didn't have anything here, remember up here we left a space and we actually started writing our quotient at the end of where we were dividing into. We're doing that same thing here. Here we have to look at just this piece and write it at the end, and then we're going to multiply back. So that's why I put the parentheses there also. So we have 4x times x will be 4x squared, and that's our goal. We want to zero that first term out. 4x times 2 is going to be 8x, and then we subtract. So then we're left with x here. Again, we should use parentheses, right? So we could, a lot of times what we have you do is write it like this. Like I would change this to plus, that to minus, and that to minus. So that way I don't get confused. Just like I do with the systems. Think of it that way. We just were adding the opposites. Okay, or when we were adding or subtracting polynomials. So we're left with x, and then we bring this down, this minus 10. And now we have to look what times x will give us x. Well, that would be a positive 1. And then we multiply 1 times x is x. And again, we're subtracting here. And then we have 1 times 2 would be 2. And then we're going to just change our signs to their opposites. And we get x minus x is 0, negative 10 plus negative 2 is going to be negative 12. And this is our remainder, right? So then we want to write that up here as remainder of negative 12, and that's over x plus 2. So how we write our answer is going to look like, so it keeps blowing up on me today. So we're going to take this and write our answer in a nice clean format. 4x plus 1 minus 12 over x plus 2. So it looks a little different, a little strange, but that is division of polynomials. We're not going to do this other one over there. Skip. There is this method called synthetic division that I'm going to show you really quickly if you want to see it and note it for later. But you don't have to do that. You can stop there and that'll be optional. So you can just move on from here, but you'll learn. We review over this a little bit in Math 99 and 141. So I'm just going to quickly bring you through the synthetic division. This is optional. So first thing you would do is write down everything for the coefficients that you have for your dividend. So that's coefficient of dividend. Just write them in a line. Then I draw in this like just little I don't know, chart bar. Then I take the constant of my divisor and I change it to the opposite sign so that everything I'm doing is addition, just like I did earlier, so that it just makes it easier to work with instead of having to make that transaction. The first thing we want to do is just bring this down, that first coefficient. And then we just kind of do this multiplication process and subtraction process on a diagonal, similar to what we did in the long division. So we're going to do 2 times, or negative 2 times 4. That way we have the signs we want. And that is going to go right in here. That'll be 8. Okay, so we're multiplying the negative 2 times the 4. That's what happened here. And that goes right under the second, in the second row. And so then we go ahead and add those together and I get a plus 1. All right, now we're going to go again and we're going to multiply the negative 2 times the value in my next row. And that will go in the third, column. Third column. So that'll be minus 2 there. Okay, and then I'm going to add these. So these add, and I get my minus 12. And that piece goes over the divisor. That's the remainder, and I should put my x in there too. And so for my final answer, I get the same exact thing as I did with the long division. It's just I'm using a little pattern, kind of more like a puzzle. And when you have longer, more complicated things, then that's helpful. So just a little taste of that. You're not required to do that. And this problem you can skip also. Okay, so have a great day.